Hello everyone, welcome to AWS Tutorials. In AWS Tutorials, you learn about AWS services. Today, I am going to talk about how to build ETL pipeline using AWS Glue and step function. I have been doing a couple of sessions on building the ETL pipeline, and I do discuss what different choices we have. And in the continuation of that whole discussion today, I'm going to talk about how can you use glue and step functions to build an ETL pipeline. So let's get started. So how does a typical ETL pipeline look like? Generally, you will have some kind of data source. For instance, here in this case, you have some JDBC data source. Then you use AWS Glue job to ETL that data into, say, S3 raw bucket area. We are calling it raw because you keep data immutable in raw bucket area, and this data, you don't do any business transformation on this data. It's just loaded as it is from your source. And then once you load your data into your raw bucket area, then you use crawler to simply catalog your data so the data is discoverable and searchable. Once your data is in the raw bucket, you use another glue job to convert your data into cleansed data. Now your cleansing operation could be anything depending on your business need. It could be as simple as standardizing the column names, or standardizing the currency format or date format, or it could be removing duplicate data, anything like that depending on your business need. But once your data is populated into your cleansed bucket, you then again run glue crawler to catalog your data. And finally, you use another set of glue job to convert your cleansed data into curated data. You not always create curated data, you create curated data only based on the use case. So if you want to do use cases like creating reports or dashboard, or if you want to do machine learning, then you use glue job to create another set of data for your use case purpose only, and you keep that into the curated area. And again, you use glue crawler to catalog your data. So that's how a typical ETL pipeline look like. It could be different, but depending on what your business requirement is, but that is typically how it will look like. And there are three ways you can use to build your ETL pipeline. Either you can create an event-based framework, or you can use a glue workflow, or you can use step function. I have already covered 3 sessions actually. In one session, I compared each of these 3 approaches. In another one, I talked about how you can create an event-based pipeline. I also have another session where I discuss glue workflow. So today, I'm going to focus on the third approach, which is using step functions to create a pipeline so that it completes the whole circle. Okay, so today's focus is on the step functions. Now, if you're trying to use a step function, this is how your typical pipeline look like. Actually, I mean, again, it depends on business case to business case, but basically, you will be running couple of glue jobs as a part of your pipeline, and these glue jobs are primarily responsible for extracting, transforming, and loading your data. So they do data manipulation and data storage. And then you also run couple of crawlers, and these crawlers are responsible for just cataloging the data. So generally in any ETL pipeline, you will be running these set of crawlers and glue jobs in a certain sequence to complete your ETL pipeline. Okay. So, and we will be building one such pipeline towards the end of the presentation to demonstrate how it works. Now, when you're trying to build a step functions based pipeline, you need to be aware of certain pros and cons. So for instance, when you're trying to build a step function based pipeline, basically you're doing a pipeline by pipeline development. So suppose you have got like some 10 data sources and some 70-80 different ETL pipelines, then you have to do each of these ETL pipeline development independent using step function workflow. So you can create reusability at the job level or even at the crawler level sometimes. So you can create reusable crawlers. Primarily you create reusable jobs. There you can get reusability, but end of day you create your whole development is pipeline by pipeline development using step function state machine workflow. From observability point of view, and this comparison I have discussed earlier as well, but for those who has not seen my previous videos about comparing the different approach for the creating ETL pipeline, I'm just putting it one more time so that it is helpful for guys who have not seen those videos. So talking from the observability point of view, having observability is very important for a data platform because you want to keep an eye of how many data pipelines are executing successfully, how long they are taking to execute, how many are failing, why they are failing. So observability is very critical from that point of view. And in case of step function, you can use out-of-box visibility, because step function provides you pipeline by pipeline, stage by stage execution tracking. And so you can really get to know about pipeline level execution status using the observability features of step functions. From development effort point of view, it can give you really an early win, because all you need to do is define your crawler, define your job, and start creating your state machine workflow. So you don't need to do a lot of prerequisite work, a lot of upfront development in order to create your pipeline. As long as your required jobs and crawlers are ready, you can start creating your pipeline. So you can really show early wins using this approach, because if you have things in place, probably in a couple of days you can start showing a couple of pipelines running. Okay. And your development effort is quite consistent. It could be more, it could be less, depending on the complexity of the pipeline, but it does not change over a period of time. It is pretty much consistent development effort, pipeline by pipeline. One of the best part of using this approach is this step function provides out-of-box integration with most of AWS services. So if you want to integrate with other AWS services, step function, it becomes very easy within the step function. So for instance, some of the popular use cases I have seen is that people wants to track the success and failure execution of their ETL pipeline, and they want to be notified about it. Especially if the pipeline is failing, they want to be notified about it. And such notification you can send using SNS, Amazon SNS service. And integrating Amazon SNS service with step function is very easy because it provides out-of-box integration with that service. So use cases like this you can easily build using the step functions. And the last one is from the development environment point of view, you can use Step Function Workflow Designer. This is a new UI-based tool which you can use. In fact, I'm going to use this tool today. This is a new UI-based tool which you can use to develop your pipeline. When you create a state machine workflow in Step Function, it is end of day a JSON document. So yeah, feel free to write your own JSON document. But if you like GUI and drag and drop kind of approach, then yeah, you can use Workflow Designer in Step Function to create the pipeline. So having understood this pros and cons of using step functions to build a pipeline, let's get started about the design part of it. So how do you start? So as I mentioned earlier, that when you're creating a pipeline, basically you're starting a job and starting a crawler in a certain sequence. So first thing, let's try to understand what it takes to start a job. Now, starting a job, very simple thing, because AWS Step Function does provide a task for starting the job. And configuring this task is pretty straightforward. You have to provide job parameters in a JSON document. So your job parameters could be job name or parameters passed to the job. Well, job name is mandatory because unless it knows the job name, it cannot start the job. So that at least job name is mandatory. But if you want to pass other parameters to job, for instance, sometimes people pass certain command line parameter or runtime parameters to job. Those things also you can pass using this job parameters JSON document. Then you can decide to run in a synchronous or asynchronous manner. So running a job is a long process, right? Depending on how much data you're extracting or what kind of transformation you are performing, it could be really a long running job. So you can decide to run configure your glue running the glue job task in such a way that you wait for job to finish before you go to the next step. You can do that way, or you can simply run in an asynchronous manner. That means you fire your job run and then you move next to the next step. You don't wait for job to finish. So again, people go for both of approach depending on their business logic. If you have to wait, you configure it for synchronous or wait type of run, where you start the job, you wait for job to finish, and when job finishes, then only you move to the next step. Or you can also configure it to run like fire and forgot type, where you simply start the job and move to the next step. And the last thing, of course, you have to define the next state, which is like once the job is done, what you do as a next state in the state machine workflow. So these are the parameters you can configure to start your glue job, and I'm going to do it and show you how it works. So moving on, how you can start a glue crawler, and that's where things start becoming little tricky because there is no out-of-box task for glue crawler. So like glue job has a task for itself, right? You simply can configure it and you can start a job in a synchronous or asynchronous manner. But there is no out-of-box such task for glue crawler. And glue crawler is also is a long execution, is a long running process. It can really take a long time depending on how much data you have to scan. So it is a long process. So how do we handle such scenario? So there are two approaches which are available, and approach one is that step function task does provide a way to invoke crawler API. And then in that case, you can control your execution depending on your waiting for, using the method called wait for task token. So this is one method where you start the crawler job and then you provide a token, and unless some external process tells this step function back that the task with this token is complete, it will not execute further. So literally you can use this kind of event-based mechanism to control the execution of your state machine workflow, and you can make this crawler, when you start the crawler, you can make the workflow to wait until the crawler is finished the task. So that's one approach. Other approach is that you can use simply Lambda task with the custom code. So you can, it's like you can create two Lambda function, and both could be very much like a reusable Lambda function. One Lambda function is primarily responsible for starting the crawler. So all it does is start the crawler, nothing else. And the other Lambda function will simply get the status of the crawler. And you can use then these two Lambda functions in your business logic to follow both kind of path. Whether you want to simply start the crawler and move on, you can do that as well. Or you want to start the crawler and use this get status of the crawler Lambda function to get the status of the crawler, and depending on the crawler has finished the job or not, then you decide to move to the next state, or you wait. Yeah. So today what I'm going to do, I'm going to take the approach number 2. Though I personally like approach number 1, but if I talk about approach number 1, I need to spend some time talking about wait for task token method. So I'm thinking to use some other tutorial to talk about this particular approach, and I will talk in more generic way that time, not just in the context of glue crawler. But keep this approach one in mind, guys. If you want to explore by your own, you might want to you follow the approach one to make a event-based mechanism to control the execution. Otherwise, there's always approach number 2, where you can create 2 Lambda function, 2 reusable Lambda function to control the execution of the workflow. So let's move on. So I'm going to use approach 2 today, though I personally prefer approach 1. Moving on, so how do I start a glue crawler? So basically, let's say how the business logic look like. So if I'm taking the approach number 2, in the business logic, I first start the Lambda function. I start the crawler using the Lambda function, and I don't wait. I simply fire and forgot kind of thing. So I'm starting the crawler. Then I call another Lambda function, which is checking the status of the crawler, which I have just started. And then we check when the crawler status turns ready, because when the crawler you run the crawler, actually the status changes from ready to starting to running to stopping, and from stopping to ready again, if I'm not wrong. So we are waiting till since you have started the crawler, now you want to wait when the crawler status again turns back to ready. Until the time it turns back to ready, you want to keep checking the status, because crawler has not finished the job. But the moment the status comes back as ready, you know that your crawler has finished the job, and now you can move to the next state. So that's how you can build your business logic. So how does the Lambda function look like? So if I'm trying to create a start crawler Lambda function, how does that look like? So in this case, you provide in your Lambda function an input through the state machine workflow, and your input could look like a simple JSON document like this, where you simply provide the crawler name. Then you write your code, and in this code you can see over here I am first extracting the crawler name from my input, and then I'm starting a glue client, and then I'm simply calling the start crawler function to start the crawler. Again, I'm using a Python code as an example here, but you can use whatever language you prefer, and of course syntaxes will be different, but business logic will remain the same. So basically, you extract the crawler name from your input, and you create the glue client, and then you simply start the crawler. Now crawler has started, and at this point of time, as an output, you can decide to say, okay, I'm not going to get any output, so you decide to get nothing as an output. Like in this example, there is no output here. But other way could be that you might want to return back a run ID. So when the crawler runs, you get a run ID for the crawler, and that run ID you might want to return back, because then that you can use to get more information about that crawler run. So it could be very useful information to get more information about that crawler execution. So choice is yours depending on your business logic. Either you want to get the run ID back so that you can use that run ID for any further query, or you simply decide to say, no, I'm not going to get any output back. Then the second method is, which is going to fetch the crawler runtime status. And in this case, again, you provide an input, and input looks very much similar. You are simply passing the crawler name. Then you write your business logic, and in your business logic, actually, it's pretty straightforward. Again, you simply extract the crawler name, then you create a glue client. Then you want to get the crawler information, And when you get the crawler information, you also get a state information. And as I mentioned earlier, state information changes from ready to starting to running to stopping, and stopping to ready again. So this state information you want to return back as an output. So you simply return the state information back, and this state information is then used to build your business logic, where you tell your workflow whether to wait for crawler to finish or simply move on. Okay. So that's how your crawler function look like. Now, if you want to use the, like remember when we're starting the crawler, you get a run ID back for the crawler execution. If you want to use that run ID to fetch some crawler execution statistics or information and use that in business logic, you might want to pass a run ID also as a parameter. And then with that, you can build even more complex business logic to fetch more information to decide about your workflow execution flow. But in the simplest form, this is how a function might look like. So let's see a demo of this whole thing working together. All the code I showed you, I'm going to provide you as a in the description box below as a Python file link, and you can definitely use that code snippet in case you want to test it at your end. So this is the workflow which I'm going to create today using state machine workflow, or a pipeline using state machine workflow. So I have a RDS database where I'm simply have a customers table. Then I use a glue job 1 to populate my data into raw table in a CSV format. Then I crawl that data. Then I run another job to move the data from raw to the cleaned. And only transformation I'm doing over here is I'm converting my CSV file into a Parquet format. And then I crawl my data again. So this is the pipeline I'm going to build today. And this the box I'm showing over here, this box is the pipeline I will create as a part of my state machine workflow. So in my state machine workflow, first my job 1 will start. When my job 1 finishes, my crawler 1 will start. When my crawler 1 finishes, my job 2 will start. When my job 2 finishes, my crawler 2 will start. But when I run the crawler 2, I'm not going to wait for crawler 2 to finish, because crawler 2 is a last step. It can finish by its own whenever it wants. So let's move on and see how to build this pipeline. So here's my AWS console. You can see here I have got my raw cleaned folder over here, and then I have got a script folder where I can keep my scripts. In my glue job, I have got my source database catalog, and I'm going to use this customers folder over here, customers table over here. Then I have 2 crawlers, in fact 3 crawlers. The source crawler is simply crawling my source RDS database, but then I have crawler 1 and crawler 2. Crawler 1 is responsible for crawling my raw data, and crawler 2 is responsible for crawling my cleansed data. Then I have got job. My one job is which is taking data from RDS and populating into my raw area. So you can see the script over here. So it's simply from Dojo database. It's reading the customers table, simply populating the data into data frame, and then I'm writing to S3 raw customers folder in CSV format. Simple, yeah. And if I go to the second job, here's how its code look like. Second job is simply reading data, my raw customers data from again Dojo database. And then I'm simply writing that, populating the data to a data frame. Then I'm writing the data frame to S3 bucket, and location in this case is cleansed customer, and my format is Parquet. So I have written a very simple 2 jobs for testing purposes. So I can see here my raw and cleansed data is not ready, and those buckets are also clean over here. So let's see the first code. First Lambda function which I'm going to use is going to use the start crawler Lambda function, and this code you have seen, and this Lambda function is responsible for starting the crawler. That's it. And then second Lambda function, I'm using it get crawler function, and this Lambda function is simply giving me back the state of the crawler so that I can use that state information to create the business logic. Now let's create a state machine workflow. I have already created a sample workflow over here just in case something goes wrong and I want to use this one. In fact, I could not get time to test it, but I'm hopeful it will work. But let's create a new state machine workflow. So let's create a new workflow over here. So I'm going to use Visual Designer. I'm creating a standard workflow, and here I come to my designer. So what I'm going to do is first I'm going to drag and drop my glue job. Then I want one Lambda function, one another glue job, and then one more Lambda function. Okay, so let's name this one saying job 1 start. This one will be crawler 1 start. This is job 2 start. Generally I try to give a name first because then it's easy for me to identify, and then it is my crawler 2 underscore start. So let's try to configure first jobs. They're easy to configure. So if I go to my job 1, it says okay, fair enough. So what is your job name? And in this case my job name is job 1, and then I'm saying that hey, wait for this task to complete. So don't simply start the job and then move to the next state. Start the job, wait for job to finish, and once job has finished, then only move to the next step. So I simply keep it like this. Okay, so this is done. Now let's similarly do job 2. So job 2, you can see here I need to provide the job name, so I simply provide job name as job 2, and in this case also I'm saying hey, wait for job to finish, because I cannot crawl my data if I don't create my data. So I have to wait for my job to finish and then only I crawl it. Okay, so I will do one thing. I will move next and let's save it. Okay, stay and fix what it's saying. Okay, we have to provide the state function name. Okay, fair enough. Let's do this one. So in this case, I have to provide the crawler start thing. So I come over here and say this is my start crawler function. And in this case, I'm using a Lambda function, simple, and I want to use my payload. So enter the payload, and in my payload, I simply want to say that this is run the crawler 1. So I'm simply providing crawler 1 as the parameter. Nothing else I'm going to touch over here. Now if you look at the other function here also, I want to provide the function name. So I simply come over here and I say I want to start my job. So I say start crawler function. I want to enter my payload, and my payload is in this case crawler 2. So crawler 2. Okay, so let's move next. So I'm not complete my business logic, but I want to save this one. So you can see here I'm running my job 1 in a synchronous manner. Then I'm invoking a Lambda function, which is start crawler function with crawler 1 as an input. Then I'm starting my job 2 in a synchronous manner, and then I'm starting my crawler 2 using the Lambda function. Okay, so let's move next. This one, give this a nice name, so I can say Dojo ETL pipeline. And in this case, I'm going to choose an existing role. So this role I have created, and this role has permission to start Lambda function, start crawler, and start glue job. So you need at least that much permission for this role in order to perform the state machine workflow. So now my workflow is created, but I'm not done it, so I'm going to edit it again, and I simply use my workflow studio again to edit it. So right now what's doing is that it's starting my job, then crawler, then job, then crawler, but my crawler does not have any wait functionality because it's a simple Lambda function. So when I run the Lambda function, it's going to start the crawler, and then it will say, hey, I'm done, and it will start running the job 2, but my crawler 1 is not done yet. And since job 2 uses the catalog created by crawler 1, my whole business logic is going to fall flat. So what I'm going to do is that I'm going to stop my crawler my job 2 execution till my crawler 1 has finished. For that, I'm going to use another Lambda function, and this Lambda function, I say this one will be I will say get crawler 1 status or state. Yeah, let's choose state. And then you come back here and say the function name is get crawler function, and my input again is enter an input. And in this case again I'm going to use my input as the crawler 1. Yeah. So this input will be provided to my Lambda function. So I'm done with that. So this one will fetch my crawler status. Now I need to wait. So I am going to use a choice over here. So I simply drag and drop choice over here. So now what I need to do here is that. So let's minimize this one. I will open it later. So here I've got a choice, and let's configure it. So let's configure so default rule is simple, that hey, I simply go to job 2 and then crawler 2, but I want to modify this rule. So here I'm going to modify the rule and say let's add a condition, and condition is that if not, my output dot state. So remember the Lambda function, guys. In a Lambda function, I'm getting output in a JSON document where state is one of the fields. So from that, I'm fetching the state field value, and I'm going to compare is equal to, say, string constant, and that string is ready. Ready. Save condition. So I'm saying if my state is not equal to ready. So if not equal to ready, I don't want to move forward, right? So in this case, I simply want to go back to my crawler start 1, not crawler start 1, get crawler state 1, yeah, like this. So you can see over here that my business logic is pretty straightforward. So I'm saying that, okay, you start the crawler, then get the crawler status. Here you check that if my default rule says, so if I close it, my default rule says that if my state is not equal to ready, go back to get crawler state 1. But otherwise, you simply move on to default flow, and default flow is pretty straightforward. Go and run the job 2. So simply continue. So this is fine, but there is no wait time here because it will simply run in a very fast loop, and it's not good because you are necessarily running a Lambda function while you might want to wait my Lambda function for a couple of seconds. So to do so, I'm going to introduce a wait condition over here. So I'm simply going to say wait, and if I can put a wait over here, yeah, so here we go. So now this is how my business logic look like. So I'm saying that, okay, if my rule 1 follows, then you simply go to the wait condition, and I'm going to wait for, say, 3 seconds, something like that, and then go and check the status again. So instead of running like loop again very fast, I'm simply saying that here, if my choice 1 is mate, go to the wait state, and then from wait it will go back to the fetch the crawler status again, and then run the choice, evaluate the choice again. So this loop will keep running till the crawler is back to ready state. When the crawler is back to ready state, it will simply move on to the this job over here. So let's see again. So wait is 3 seconds. Okay, fair enough. Now my job 2 is already configured, and here I'm not checking any. I can do and check again, like here in this case, but I'm not doing the check over here for the simple reason because this crawler is my last crawler. I don't need to wait for it to finish because there's nothing after this. So this crawler can take its own time and finish. I really don't care about that part. So with this, I simply apply and exit, and then I simply save it. So here my business logic is created. I simply save it. So now my my workflow is configured. Now I'm going to start the workflow, and this workflow will first run job 1, then crawler 1, then it will wait for crawler 1 to finish. When the crawler 1 finishes, it will run job 2, and when job 2 finishes, it will run crawler 2, and then it will simply complete the whole flow, and when crawler 2 can take its own time to finish the work. So let's start the execution. Okay, and start. I have no input here, but if you have inputs, you can provide some input over here. So I'm simply starting the execution, and you can see here my execution has started. Now I have to wait for my my workflow to finish because it's going to like run this whole flow, and this will take quite some time. So what I'm going to do, I'm going to wait till my workflow has finished the execution, and then once it is done, I will show you what it has done as a part of the workflow. So let's wait for it to finish. Okay, so you can see here the step function has finished the execution. It has completed each of the tasks successfully in the pipeline. Now I can verify the status. So you can see here, if I check my my crawler status, you can see here each of my crawler has created and updated some table. If I go to my tables, you can see here it has created my raw customers as well as clean customer catalog. And if I go to my raw and try to see my customers folder, I can see some data files over there which are partitioned. Then similarly, if I go to my cleansed folder, you can see my Parquet data format in the cleansed bucket. So you can see over here that it has the pipeline has succeeded, and it has completed the sequential run of your jobs and crawlers to complete the task end to end. So that was all for today's tutorial, guys. You learned how you can use step functions to create pipeline using AWS Glue Job and Glue Crawler. So hope you like the video, and if you like, please click on like button. Please subscribe to my channel, and I always look forward to your feedback, your comments, in order to create new content or to discuss if anything I have presented wrong, you want to correct me, or if you want to discuss any of the topic which I have presented about, like you have some design questions, some follow-up questions, something you want trying to do something similar and you want to discuss with me, feel free to provide your comments into my YouTube channel comment section, and I generally try to give answer as soon as possible. So look forward to your comments and feedback about these tutorials, about other tutorials. I promise to come back again in a week's time with another such tutorial. In the meantime, stay safe and have a nice day. Bye bye.